General Contractors of America.
Every day, our industry requires people to work at different heights. Sometimes close to the ground, other times hundreds of feet in the air. Everyone knows the danger of a fall, but as the building goes up, you become more comfortable with your surroundings. It's when you're too comfortable that a disaster could occur.
You've just seen how easy it is to become the victim of a fall. Even for people who are normally cautious, it only takes a moment for a person to end up badly injured or dead. OSHA estimates there are over 68,000 injuries due to falls, where the OSHA Subpart M fall protection standard would apply. And the impact of one of these accidents doesn't stop with the person who's been hurt. Falls take their toll in human terms: family hardship, lost time from work, and low morale on the site. The good news is that injuries can be minimized with a well-managed fall protection program. This includes pre-planning of potential fall exposures, comprehensive training, and using the right equipment. The program also includes enforcing fall protection procedures and disciplinary action for those who don't comply. You may already know something about fall protection, but the fact is, the OSHA standards have changed. And that means you might have to change some of the fall protection procedures you've been using.
The biggest change is that you must have fall protection whenever there's a chance of falling 6 feet or more. 6 feet may not seem like very far, but workers have been killed from falls less than 6 feet.
You have to know what fall protection will protect you most effectively. In general, there are 8 types:
guardrails, safety nets, covers, personal fall arrest systems, warning lines, controlled access zones, safety monitors, and a fall protection plan. Guardrails are common on construction sites. A guardrail is made up of a top rail, mid-rail, toe board, and posts. The top rail should be between 39 and 45 inches above the walking level. Mid-rails should be located halfway between the top edge of the rail and the floor. The only exception to having mid-rails is when a wall or parapet comes up 21 inches next to the guardrail. Then the wall provides the necessary protection. When constructing a guardrail, choose materials with a smooth finish that won't cause lacerations or snag clothing and cause a fall.
The guardrail should be strong enough to withstand a force of up to 200 pounds, applied within 2 inches of the top edge in any outward or downward direction.
Wood, pipe, structural steel, and cable are all good materials for constructing guardrails. When using wood, choose stress-grade construction lumber. The posts and top rail should be made of 2x4s. Mid-rails should be made of at least 1x6-inch lumber. For pipe guardrails, posts, top rails, and mid-rails should be at least 1.5-inch diameter of Schedule 40 pipe. When using structural steel for guardrails, posts, top rails, and mid-rails should be at least 2x2 by 3/8-inch angles. If you choose cable for a top rail, it should be a 1/4-inch nominal diameter or thickness and marked at 6-foot intervals with a high visibility material so people can see it. And never use steel or plastic banding for top rails or mid-rails. No matter which material you choose, OSHA requires that posts be spaced no more than 8 feet apart.
Make sure there's no overhang on the end joints that could catch on clothing or cause someone to trip.
Toe boards are attached at the walking level and keep people from slipping over the edge. They also hold back tools or materials that could fall on someone below. Toe boards should be at least 3.5 inches high and made out of wood or another solid material, and with openings no more than 1 inch at its greatest dimension. Tow boards must be able to withstand 50 pounds of force in any downward or outward direction at any point along the tow board. Remember to regularly check guardrails for cracks or wear and replace them if necessary.
Another type of fall protection is the safety net. Safety nets are made out of strong synthetic materials with holes no more than 6 inches at its greatest dimension.
They should be installed as close as possible to where people might fall, but never more than 30 feet below the level they are designed to protect. Net extensions vary. The longer the potential fall, the bigger the net should be. For example, if the net is 5 feet below the working level, the net should extend a minimum of 8 feet away from the building. If the net is 5 to 10 feet below the working level, the net should extend out 10 feet. If the safety net is 10 to 30 feet below the working level, the net should reach out a minimum of 13 feet. You may have to use more than one net to provide adequate protection. If so, make sure the connections between the nets are no more than 6 inches apart and that the connection material is as strong as the rest of the net.
Just like the other equipment, you should always test a safety net to make sure it'll work when needed.
You also need to monitor the safety of the net after it's in place. Immediately remove anything that falls into it, such as construction tools or materials. You don't want someone injured because they landed on scraps or tools. Check nets once a week for mildew, stress, or any other signs of wear. If you find problems, remove the net immediately and replace it.
The third type of fall protection is a cover. You're required to keep covered any gap or void 2 inches or more in dimension on a floor, roof, or other walking or working surface.
Covers should be made of a strong material that will support twice the total weight of a worker, equipment, and materials at one time, and twice the maximum weight of the axle load of any vehicle expected to cross. Make sure you write the word hole or cover in large, easy-to-see letters, and make sure the cover is securely in place.
A personal fall arrest system is specially designed to protect you in a free fall situation. In a free fall, your body weight combines with the speed and distance of the fall to create tremendous momentum. And when you're stopped, it's this sudden impact that actually causes injury.
Personal fall arrest systems are designed to help protect you not only from falling, but also from being injured by the force of the fall. A personal fall arrest system has 4 components, and the whole rig must be in good working order, including a full body harness, a lanyard, snap hooks, and an anchorage point. For this equipment to be most effective, you have to be familiar with each part of the system and how it works in different situations. A body belt can be used effectively as a positioning device, but it's not ideal for use as part of a fall arrest system. In fact, after January 1st, 1998, body belts won't be permitted for use with fall arrest systems. Body belts just aren't good in a free fall situation, and here's why. When jolted by a fall, body belts cause you to jackknife, sometimes violently. You may be injured by the belt itself, and hanging like this can lead to internal injuries. To reduce the impact caused by a fall, a full body harness is your best bet. It helps keep you from getting hurt by distributing the force evenly over your pelvis, thighs, and shoulders.
Lanyards are the next component. They connect you to the anchor point and attach to the body harness between your shoulder blades.
There are 3 different kinds of lanyards: nylon webbing, rope, and shock absorbing. Each has unique qualities that can make a difference in a fall. The web or strap lanyard is strong, but it has no give, so your body ends up absorbing the full force of the fall. Rope lanyards absorb the force of the fall by stretching upon impact. Shock-absorbing lanyards are designed to absorb most of the force of a fall. They are also called deceleration devices because they slow and eventually stop your descent. These devices are activated by the fall. You may have seen the 4 different kinds of shock-absorbing equipment: rip stitch, specially woven, rope grab, and self-retracting lifelines.
Let's take a closer look at how the type of lanyard you use affects the amount of force on your body.
We use 220-pound weights to test all three kinds of lanyards, strap, rope, and shock absorbing, to measure the amount of force absorbed during a fall. As you can see, there's quite a range of force, so the lanyard you choose can make a difference in reducing the force of the fall.
To connect the lanyard to the D-rings on your belt or harness, you'll need to use snap hooks. These are your connection to safety.
Snap hooks should be made of smooth, corrosion-resistant steel and are double locking. Non-locking snap hooks will be prohibited after January 1st, 1998. When using snap hooks, be sure to attach snap hooks only to D-rings or the anchor point. Always follow the standard rule: one snap hook, one D-ring. And use compatible hardware to prevent rollout. Rollout happens when the D-ring twists out of the throat of the hook and rolls out, causing the catch to open and the D-ring to come out. Using snap hooks and D-rings that are the same size and made by the same manufacturer helps prevent rollout. Once you lock the snap hook and D-ring, always check the connection each time to make sure everything is in good working order.
The anchorage point is the final part of the personal fall arrest system. This is where you attach the lanyard.
The anchorage point must be a solid, unmovable object that can support up to 5,000 pounds. Don't use an anchorage that must support anything else, like a platform or guardrail. No matter what length the lanyard is, it should be anchored at a height that will prevent a worker from falling more than 6 feet.
Remember, a personal fall arrest system should be used only for fall protection and never for any other construction work. Using it for any other reason, like hoisting material, may damage it, so it won't help you when you need it the most, during a fall.
And, as with all safety equipment, look over the entire system before you put it on. Check for tears, fraying, signs of wear, or anything out of the ordinary. If you find anything wrong, like a deformed eyelet, D-ring, or frayed lanyard, don't use it. Report it to your supervisor so it can be destroyed and thrown away. And if a personal fall arrest system has been subjected to impact from a fall, it should be removed from service immediately. The system should be inspected by a competent person who will determine if it is safe to use.
The approaches we've described so far, guardrails, safety nets, covers, personal and positional safety systems, cover many of the major hazards you face on a construction site. They can be used alone or in combination to make sure you and others on the site stay safe. Even so, there might be times when these methods are too awkward to use or difficult to construct. In these cases, you'll need to look into other methods like warning line systems, controlled access zones, safety monitors, and protection plans.
Warning line systems and controlled access zones help reduce the risk of falls by restricting entrance to certain areas of the job site. A warning line system uses rope, wires, or chains to keep people out of areas where they could potentially fall. They are often used on roofs, around dangerous mechanical equipment, or where other methods are impractical. Always make sure the lines are marked with high visibility material so they're easy to see. Controlled access zones allow only people working directly in the area to enter. These zones are indicated by a control line made of rope, wire, tape, or something similar. Like warning lines, they should be clearly marked. A safety monitoring system is another way to help prevent falls. This system uses a competent person as a safety monitor. The monitor's job is to actively patrol the work area and warn others of any possible danger. Being the safety monitor is a full-time, dedicated responsibility, and the monitor must not be distracted by other job duties if the system is going to be effective.
Another option is a fall protection plan. Under certain conditions, you may need to design a site-specific fall protection plan, but this should only be used as a last resort in situations where other options won't work.
Under the new standard, you're required to have fall protection in the following areas: around unprotected edges, including what is called the leading edge. This is where a floor, roof, or deck is being constructed and the edge is constantly changing. Depending on the activity, you should use either guardrails, fall arrest systems, safety nets, or a safety monitoring system. Where there are holes that people can fall through, covers and guardrails work best here. On ramps, runways, and walkways, use guardrails. When working on formwork, reinforcing steel, and other vertical surfaces, personal fall arrest systems, safety nets, or positioning devices should be used. When doing overhand bricklaying, use guardrails, safety nets, or personal fall arrest systems. When fall protection is needed for excavations, use fences, guardrails, or barricades. During precast concrete erection, use guardrails, safety nets, personal fall arrest systems, or a fall protection plan. And wall openings require guardrails, safety nets, or personal fall arrest systems.
All right, we've talked about 8 types of fall protection you can use. There are 2 other areas to consider in an effective fall protection program. First, don't forget about the hazard caused by falling objects like tools or materials. Tow boards help prevent this, but make sure you always wear your hard hat.
Second, there needs to be a plan to get help if a fall does occur. Know your company's rescue procedures and your role if a rescue is needed, and make sure rescue equipment is readily available.
Fall protection is an important part of staying safe on the job site. Get in the habit of taking the time for fall protection every time there's a danger of falling 6 feet or more. All it takes is a moment to plan, and you help make potential job site fall accidents a thing of the past.